This video is going to be part 2 of lesson 1. In lesson 1, I introduced you to the fundamental counting principle, and all of the examples that we did in the first part involved no restrictions. What I'm going to do in this video is I'm going to introduce something called restrictions. So highlight that this is going to be involving restrictions. It's still going to be the fundamental counting principle, so we're going to set up our stages and the number of choices in each stage, and we multiply. However, we're going to be given something called restrictions. So what's really important to remember when we have restrictions is that we deal with the restrictions first. So I'll show you what I mean with that. What it says is Eric has been assigned the task of determining how many odd 4-digit numbers there are. So the first thing is 4-digit numbers. That would be 4 stages, right? And then what we have to do is we have to figure out, he wants to know how many odd 4-digit numbers we have. So normally we said that the digits go from 0 to 9, and there's 10 digits total. But we know that an odd number is made by this last digit here, and I can't put 10 digits here because if I put the number 0, the number 2, 4, 6, or 8, that is going to be an even number. And the restriction is it must be an odd number. So we couldn't put in this last stage 10 total digits because if I said, well, what are the odd digits? What makes a number odd is that last stage, and if a number ends in 1, 3, 5, or 7, sorry, 1, 3, 5, 7, or 9, it will be odd. So what that means is that odd numbers have 1, 2, 3, 4, there's 5 possible choices. So this last stage, if he wants it to be an odd number, it could only be 5 possible choices. So what it says is the first step of his work is shown. Explain his reasoning for the number 5. So he set up his 4 stages because he wants a 4-digit number. And the reason why he put 5 here is because he has 5 choices for the last number, a 1, a 3, a 5, a 7, or a 9. Okay? The second step of his work is shown. Explain his reasoning. Why did he put 9 possible choices here when we know that 0 to 9 is 10 possible choices, right? There's 10 choices there. If you read up in the question, it says he was told that a number such as 5267 is a 4-digit number, but 0267 would not be classified as a 4-digit number. It would be classified as a 3-digit number. So what that means, if you read this and if you interpret it correctly, it means that the very first number could be any of these numbers except for 0. Okay? So the reason why he has 9 possible choices is because the first stage could be the numbers 1, 2, 3, 4, 5, 6, 7, 8, or 9, but not the number 0. So not the number 0. So we had 10 possible choices. We're taking out the number 0, so we're taking out one of our choices. So that gives us 9 possible choices in the first stage. Then what it says is complete his work to determine how many odd 4-digit numbers there are. Okay, so odd. We know that we put in our restrictions first. The first restriction is that this number is either a 1, a 3, a 5, a 7, or a 9. The second restriction is we can't start with 0. So it can't be 0. So I'm just going to write not 0. So that gives us 9 possible choices. There were no restrictions here. So the middle, it could be any number. So can be any number from 0 to 9. So there's 10 choices there, and there's 10 choices there. There were no restrictions for the middle. So our answer is going to be 9 times 10 times 10 times 5, which gives us 4,500 possible odd 4-digit numbers. Okay, so we're going to look at a couple more examples where we're going to be dealing with restrictions. Okay, so let's continue on with another example and see if we could get more comfortable with these restrictions. So this example says the total number of choices may decrease if repetition is not allowed. So I'll show you what this means. For example, determine how many three-digit numbers can be formed using only the digits 7, 8, 9. So first of all, three-digit numbers, how many three-digit numbers? That would be 3 different stages. And then what's happening is they're only giving us these 3 numbers to choose from. So I only have 3 choices in each stage. So what they say is repetition is allowed. Repetition is allowed. What that means, if repetition is allowed, is that, okay, they want to know how many 3-digit numbers I could make from just the choices 7, 8, or 9. So repetition is allowed means that I have 3 choices available there in my first stage. I have 3 choices available in my second stage, and I have 3 choices available in my third. I could use a 7, 8, or 9 here, a 7, 8, or 9 here, and a 7, 8, or 9 here. Repeats or repetition is allowed. This would give me a total of 27 three-digit numbers can be formed. Okay? Now we're going to look at what's going to happen if repetition is not allowed. So we still have 3 different stages, and the numbers that I have to choose from, they said, are 7, 8, or 9. So in my first stage, I have 3 different choices. If repetition is not allowed, what that means is once I've used one of these numbers, in the second stage, I only have 2 choices. And then in the third stage, I'm down to 1 choice. So in the first stage, I could have used the 7, 8, or 9. In the second stage, if I can't use repetition, I only have 2 choices. And then in the third stage, 1 choice. So if repetition is not allowed, I decrease from 27 possible ways to 6 ways that a 3-digit number could be formed. Okay? Okay, so let's look at this now. Eric has been assigned the task of determining how many odd 4-digit numbers there are, and now they're doing one more restriction, and there's going to be no repeating digits. So here's the thing. What we did from the previous example, they want 4-digit numbers. That is going to be 4 stages. We need to start with our restrictions, and I always like, if it's odd, I always say, okay, how many odd numbers can I fit here? So we know that out of my 4 stages, if we're doing an odd number, I could have 5 possible choices here, because I still need the last digit to make it odd to be a 1, a 3, a 5, a 7, or a 9. So there are 5 possible choices. Okay? Now I'm going to go to that first digit. So the first digit, in the previous example, we said that there were 9 choices. And remember that we said, okay, normally we have the numbers 0 to 9, which is 10 possible numbers, but we can't use the number 0, right? So because we can't use the number 0, I'm going to take away one of my choices, and I've got 9 possible choices. But then I can't use a repeating digit, right? So whatever digit I chose to go here, I cannot choose that same digit to go here. So I have to take off one more choice, and I only have 8 choices here. Okay, so there's 5 choices that make it odd. Then going to here, it can't be a 0, and it can't be whatever number I selected here. So I'm taking away from my 10 possible numbers to choose from, I'm taking away 2 numbers. So it says the first digit can't not be a 0, and it can't repeat the last digit. Okay, so I had 5 choices here. I have 8 choices here. All right, let's go now. And I'm actually not going to use this chart, and we're just going to fill in the rest. So what we had was we had 5 choices here, because this is our odd number. There's 5 possible choices. Normally, if repeats are allowed, I put the number 9 here because we can't have 0, but they also said we can have no repeats. So I had 9 choices minus this guy, which is 8 total choices. Okay, so now we have to say, how many choices do I have for these two? There was generally no restrictions here. The only restriction for these two is they can't be repeats of these. So what you have is this one here can't repeat the first or the last. So the first or the last number. But 0 is back in the game. Right? So from the numbers 0 to 9, I have 10 total choices. From this, I have to subtract 2. So I have to subtract whatever number went there and whatever number went there. So that means that I actually have, because 0 is back in the game, I've got 8 possible choices there. And then for this third number, it's going to be the exact same as this, except I had 10 possible choices. Now I have to subtract 1, 2, 3 numbers to give me 7 possible choices there. So when I have the restrictions of it being odd, I can't start with a 0 and I can't have any repeats. This is what my number would look like. This is how many choices I would have. So 8 times 8 times 7 times 5. The answer would be 2,240 choices. Okay, let's look at this question. So this was a numerical response diploma exam question. The identification code on a bank card consists of 1 digit followed by 2 letters. So you got to say 1 digit followed by 2 letters is 3 total stages. Okay, so this was a digit. Digits, remember, are normally 0 to 9 if they don't give us restrictions. Letter and letter, and normally we have 26 letters. Right? This is if we had no restrictions, I would have 10 times 26 times 26. But of course, they're going to introduce restrictions. So what it says is the digit must be odd. So this digit, I cannot put the number 10 here because it must be odd. So my odd digits are 1, 3, 5, 7, and 9. There's 5 total choices. So for my digits, I have 5 there. It says they're going to give us restrictions now on letters. The letters A, E, I, O, and U cannot be used. So they're not going to use any vowels. So we had 26 letters in our alphabet, and what they're taking out of the game is they're taking out 5 total letters. So what that means is that I now only have 21 letters that I could use. So that will go here. And then it says the third thing they're going to say to us is letters cannot be used more than once. So if I could use a letter more than once, I would have 21 times 21. But because I can't use a letter more than once, I have 21 letters available for the first or for that stage. And I would have 20 available letters for that stage, for my last stage. So using all my restrictions, putting in all my choices, and then multiplying them together, I would have 5 times 21 times 20, which is 2,100. Okay, next question that we have are these route questions. They love having this on exams, quizzes, this type of question. So what it says is we've got cities. So this is Pitland, Queensville, St. Luke, and Rutherford. And what it says is there are 2 routes from Pitland to Queensville. So if you're starting over here at Pitland and you're going to Queensville, there's 2 total routes, right? I could take that guy or I could take that guy. So going from Pitland to Queensville, there's 2 total routes. Then going from Queensville to St. Luke's, there are 3 total routes, right? So it says there's 3 routes. So I'm going to put a 3 here. Then it says there are 3 routes from Pitland to Rutherford. So Pitland is here and Rutherford is here, and there's 3 different routes you could take. And then the last one, if you're at Rutherford and you're going to St. Luke's, there's only 1 route to take. So put in your number of routes. How many routes are there from Pitland to St. Luke's? So we want to start here and we want to end here. What we would have is 2 different stages. So set up your 2 different stages. And from Pitland to Queensville, I have 2 different routes that I could take, so 2 choices. And then once I'm in Queensville and I need to go to St. Luke's, I've got 3 different routes that I could choose from. So that would be in my second stage 3. And this would give me 6 routes total. So if you start here, you need to end up there. You could get there in 6 different ways. Okay, let's look at the second one. How many routes are there from Pitland to St. Luke's, but we have to pass through Rutherford? So they want us to now go to Pitland to St. Luke's, but we have to pass through Rutherford. So we're going this way. So again, we got to go Pitland to Rutherford. That's 1 stage. This would be my second stage. So we've got 2 different stages. In my first stage, Pitland to Rutherford, I've got 3 routes or 3 choices. And then from Rutherford to St. Luke, for that stage, I only have 1 choice. So 3 times 1 is 3 routes total. Okay. How many routes are there from Pitland to St. Luke? So Pitland to St. Luke, we realized we could go in this direction or we could go in this direction. So I'm going to introduce a new word, and that's going to be or. I already told you in lesson 1, part 1, if I say and means multiply. Or is going to imply addition. We're going to add. Okay, so how many routes are there from Pitland to St. Luke? We know that we could go this way, and we would get 6 routes. Or we could go in this direction, and if we go in that direction, we would get 3 routes. So when we say this or this, what you do is you figure out how many routes in each one, and we would add them together. So or means we add. So 6 plus 3 is 9 possible routes. When you consider that we could go in that direction or we could go in that direction, there's going to be 9 routes total. So what I want you to just sort of highlight here is in any example involving or, the total number of arrangements will be found by adding. Okay, so whenever we do or, we're going to add our arrangements together. All right, let's do an example, a couple more examples, and they're going to use the letters or sorry, the word or. So we're going to add this plus this to get the total. Okay, so it says here, the telephone numbers allocated to subscribers in a rural area consist of one of the following. So it's going to be this or it's going to be this. So the first thing are the digits 3, 4, 5 followed by any 3 further digits. So what this one county does is it gives everybody is going to start with the digits 3, 4, 5. So everybody gets that. And then that's going to be followed by any 3 further digits. So we're going to have 3 stages. Okay. They say that for this one, they don't give me any restrictions. So when I have 3, 4, 5 here, then these digits here are no restrictions. So you say to yourself, okay, with no restrictions, if I have a number a number, and a number. And we know that the digits are 0 to 9. So there's 10 possible choices because it says we could have like one of their phone numbers could be 345-000. There's no restrictions. So this would be 10 times 10 times 10. And what that would give us is 1,000 choices. So don't worry about this at the beginning. You just have to worry about your stages. 10 times 10 times 10 is a 1 with 3 zeros, which is 1,000 possible phone numbers. Okay. Or the digit 2 followed by, okay, so the first digit is going to be a 2, followed by one of the digits 1 to 5. Okay, so it's going to be a 2 here. And then it says followed by one of the digits 1 to 5. So in here, this would be, the choices are the numbers 1 to 5. And the numbers 1 to 5, there's 5 total choices, followed by any 3 further digits. So 3 further digits, I'm going to have 4 stages total. They gave me a restriction on the first stage. It has to be the digits 1 to 5, so I've got 5 total choices. And then it could be any 3 digits here, including 0. So this would be 10 choices, 10 choices, and 10 choices. If you did 1,000 times 5, you would get 5,000. And then if they said that assigning a phone number, it's this or this, what we would do is we would add, and we would have a total of 6,000. Total different telephone numbers would be possible. So 1,000 this way, 5,000 this way. So this or this would give us 6,000. Okay, let's look at a question like this one, which is they love giving you a word, and then we're going to do something with that word. So what it says is consider the number of distinguishable 4-letter arrangements that can be formed from the word English. So first of all, 4-letter arrangements means 4 stages. Okay, so 4-letter arrangements means that we're going to have 4 stages. Then they're giving us this word English, and they basically are telling us that we're only going to use the letters in this word. So what I'm going to do is I'm going to count up how many words English has. So 1, 2, 3, 4, 5, 6, 7. So there's 7 total letters. So basically what we're going to be doing is we're going to be creating a task with 4 stages, and I could only use these 7 letters. And then we're going to look at the restrictions that they give us. So it says determine the number of distinguishable 4-letter arrangements, so 4 stages, that can be formed from the word English if any letter can be in any position. So what I would have is I only have 4 stages, and I've got 7 total letters. So I could put 7 total choices I have for that first stage. Once you use a letter, though, it's gone, right? So I would have 6 choices for that stage, 5 choices, and 4 choices. So if I have 7 choices, but there's only 4 possible stages, it's 7 times 6 times 5 times 4, and that would be 840 possible arrangements. B, the first letter must be an E. So they're saying the first letter must be an E. So the first stage has to be an E. If you look at the word English, there's only one E. So there's only one choice to go there. Then, once that E is gone, so we had 7 letters, right? And I used up the E. I used up one of my letters. So I've got 6 letters to go there, 5 letters to go there, and 4 letters to go there. So if the first letter must be an E, that gives me one choice for that one, times 6 times 5 times 4, which would be 120 different arrangements that I could have over here. Okay, C. The first letter and the last letter must be vowels. All right, so you got to say to yourself, what are the vowels in the English language? A, E, I, O, and U. Those are the vowels. Then look at the word English. What are the vowels in English? So in English, there's an E and an I in that word. So what that means is out of the vowels in the word that they gave me, I only have 2 vowels. Okay, they want the first and the last letter to be vowels. So the first and the last letter must be vowels. So I only had 2 vowels to choose from, right? So in my first stage, I have 2 choices there. It was either the E or the I. And once I use that letter, I only have 1 vowel left to go there. And then I have to say, okay, how many choices do I have over here and over here? We had, for this one, remember that there were 7 letters total, minus, I'm going to subtract 2 letters because I used up 2. So that gives me 5 choices for that stage, and that would be 4 choices for this stage. So 2 times 5 times 4 times 1 would give me 40 possible choices. So 40, 120, and 840. Okay, now we're going to do the most complex one. The word must contain a G. So from the English, I must have a G. So out of the 7 letters, I must use a G. Why this becomes the most complicated is because it doesn't say where the G goes. So what that means is out of my 4 different stages, the G could go here, or the G could go here, or the G could go there, or the G could go there. So I'm using the word or, which means I have to figure out how many possible arrangements I have for each of these, and then I'm going to add them together. So let's figure this out. If the first out of my 4 letters, if I start with a G. So in the word English, there's only 1 G. So I'd only have 1 choice there. Remember that I had 7 possible letters to choose from. If I use up 1 letter, I have 6 possible letters to go there, 5 letters to go there, and 1 letter to go there. So if the word must contain a G, 6 times 5 times 4 is 120 possible arrangements. Then I have to say, okay, well, they didn't say where the G goes. So the G could go here. If the G goes over here, there's only 1 G. I've got 6 choices to go there. I've got 5 choices to go there. And sorry, you guys, this should have been a 4. 6 times 5 times 4 would be 120. If the G goes here, there's 1 choice to go there. Out of my 7 letters, I've used up 1, so I've got 6 letters there, 5 possible choices there, 4 possible choices here, 120 possible arrangements. Let's figure out if the G is here. If the G is here, there's only 1 G. Once I use up that G, I've got 6 letters to go there, 5 letters to choose from to go there, and 4 letters to choose from to go there. So 6 times 5 times 4, again, is 120. Again, the G could go there. There's only 1 G. There's 6 letters available to go there, 5 letters available to go there, 4 letters available to go there. That gives me 120 total arrangements for this possibility. Because the G, they don't specify where it could be, it becomes an or question. It could be here, or here, or here, or here. So what you would then need to do, or implies that you add all of this together. And 120 plus 120 plus 120 plus 120, basically 120 times 4 is 480. And that would be your answer. So to practice this in the workbook, I want you to do questions 1 to 9, 11, 13, 16, and 17. I always assign podcasts for this unit. It looks like a lot of podcasts, 1, 2, 3, 4. There's 5 total, but it's actually only 10 minutes total for these podcasts. And the reason is students don't really get good at perms and comms unless they see just a ton of examples. And that's how you get good at this, is by looking at an example and then just practicing is how you'll get good at this lesson, this unit.